Yes, welcome to this session of Loose Talk About Physics. I'm going to look upon gravity and how it affects us. Let's think about a relatively large object, spherical, and field lines of a even larger object below, which are called isograv, just as you have isotherms, isobars, pressure and temperature. You have something for isograv as well. As we some of us know, time towards surface, or time towards any gravity well, which is significant, is slowed down towards the center, towards the massive object. Like a black hole, the time at the event horizon is almost slowed to a halt. So, and also a meter closer to a massive gravitating object is also shorter than a meter in space, where far from planets and stars and black holes. This means if a meter is less, a meter closer to the surface is less than a meter further from the surface. Let's S1, or the spatial coordinates. You got this here. So S1 is less than S2, is less than S3. S1 here is less than S2, is less than S3. If this is away from the gravitating object. So, and also time T1, this one is less than T2 and less than T3, also because time goes slower nearest the surface of things, and T2 here it goes a little bit faster. So I have this spatial coordinates here, a spatial measurement. This all fits in this Savage theorem, so that V1 is less than V2, is less than V3. And let's say S2 or T2 equals 0. Then in the middle here it becomes neutral. And this leads to that V1 is less than 0 and V3 more than 0. So it could mean that in between those isogravs here, the pressure is neutral here, in the middle of a spherical object. You can see that this spherical object goes through exactly 3 isogravs. And since V1 is less than 0 here, you get something that totally adds up to under pressure, and V3 is more than 0 here, you get something that is over pressure. And it's possible to see that if every constituent of this circle square that is over this isobar here, and this is defined as 0 in neutral, will push on its geometrical on its geometrics, and it will follow the curvature of or the geometry of this sphere, so that we should push through this one towards the subpressure here, and this creates a net force this way towards where time is slower and space is smaller. So yeah, and this is gravity on solid objects. Tend to stabilize itself, but I hope this was somewhat illuminating. T1 is less than T2 is less than T3. S1 is less than S2 is less than S3. So a meter higher up in the away from the planet or the black hole or the star is longer, because space is compressed, and so is time. The passage of time is compressed towards a heavy gravitating object like the sun or neutron star or a black hole. That's why the sandwich theorem applies here. You combine those inequalities to this inequality here, which by definition, if you say V2, where the layer in between is 0, you get this one, where V1 is less than 0, creates this under pressure in the lower part of the three isographs go over here, and V3 is higher than 0, and you get this overpressure, kinetically overpressure, and it will follow the contours of the sphere towards this one, and the net result of this speed, you see this one here, is done, because the vector goes out there and the vector that goes out there cancels out. So the net force is going towards a place where time goes slower and a meter is shorter. So that is gravity, or attraction towards a place in the universe where time goes slower and the metrics of space itself is compressed due to gravity. So that's why V1, if it's slower than 0, it is possible to see that it contracts. It sucks, it contracts, because 0 here in any direction, speed in any direction. So the sandwich theorem here, this one plus this one makes this one, and it still is symmetrical here. And this is a definition just. So there's no pressure here. And this one, those two speeds are relative to each other. So if one is negative, it creates under pressure here. And V3 is positive, gets over pressure here. And because the pressure on this end of the solid is higher, it follows down the contour of the sphere and tends to go there, and you get this net force this way. If T1 is less than T2 and T2 is less than T3, if that